For this problem, we have a bucket that weighs 20 pounds attached to point D here, and I want to figure out the force in each of the cables going to A, B, and C. So we'll start by drawing our free body diagram, which is pretty simple for this. I've got the 20 pounds acting straight down, and then I've got the forces in each of the cables that I'm trying to figure out. So what I will do now is write each force in Cartesian form. So we'll start by writing a couple of unit vectors. The first one we'll do is from D to A. Okay, so go from D to A. I move 3 in the x direction, going from 1.5 to 4.5. And I go negative 1.5 in the j direction, again going from 1.5 back to 0 in the y direction. And then 3 in the k direction, going from 0 up to 3 at A. Okay. In the B direction, that's all in the Y direction, so I won't worry about that. Moving to the DC, okay, starting here at D, I move 1.5 in the negative X direction, 1 in the J direction, because I go from 1.5 to 2.5 in the J direction, and then in the K direction, I move again up 3 in the K direction. So those are my unit vectors going from D to A and D to C. So now I can write my force equations, my equilibrium equations, some of the forces in all the directions equal 0. So in the x direction, I have 3 over 4.5 times F dA, and then negative 1.5 over 3.5 times F dC. Again, F dB is all in the j direction, so that will not show up in the x equation. That will, however, show up in my y equation. Okay, where I'll have negative 1.5 over 4.5 times FDA minus FDB. Again, that's this cable all in the J direction or the Y direction. And then plus 1 over 3.5 times FDC. That will be my Y equation. Okay, summed up, set equal to 0. And then my Z equation, again, FDB does not show up. So I have 3 over 4.5 and 3 over 3.5 for dA and dC. And then I also have the minus 20. That is the weight of the bucket that I need to include. That is in the Z direction as well. So again, I sum the forces in the X, Y, and Z direction, setting them equal to 0, using the forces in the cables as well as the weight in the bucket. So I have 3 equations, 3 unknowns. My unknowns are dA, dC, and dB. So through algebra, solving a system of equations, I can find my forces as dA equals 10, dB equals 1.1, and dC equals 15.6. So again, free body diagram, figure out all the forces in Cartesian form, sum the forces in the X, Y, and Z, set them all to 0, and solve the equations. And you get the following answer.